Good morning, chemistry students. This is Miss Huntress again, coming to you from my kitchen. We're going to talk this week again about acids and bases, but more about the differences between them. Last week we talked about acids, kind of what they look like, the fact that they contain hydrogen ions, that's the primary characteristic of them. The more hydrogen ions they have, the more acidic they are. That means they're going to conduct electricity better, they're going to react with metals to produce hydrogen gas. They're going to have a relatively sour taste, although you shouldn't taste anything in the chemistry lab. And then we have bases, which we talked about on Thursday. Bases, most of the time they end in OH, but that's not really their primary characteristic. The thing is they absorb hydrogen ions, or they absorb protons. They are slippery to the feel. They also conduct electricity. A characteristic of both of these is they change indicators' colors. Because if you look at them, they really don't look different at all. There's no way to know that this one would be sour to the taste and the base would be bitter to the taste. There's no way that this one, you would know, has a pH less than 7 and this one has a pH higher than 7 just by looking at it. I mean, if you stuck your hand in, you could tell which was which, because this one's going to be slippery and this one's going to sting. This one's slippery because it's melting your skin. So that's not a good test, to do these things. So how do we tell an acid from a base without actually, getting in any kind of danger? And the answer to that is an indicator. So that's what we're going to talk about today. We could use these pH strips. pH strips, you take a little strip out. We used these before. You take a little strip out, you put them in, and you match them up with the color scale. So if it were under 7, it would be an acid. If it were over 7, it would be a base. But who really has these hanging out in their kitchen besides, me? What else could you use? Well, according to your reference table, let's keep these organized. That one is my base, and this one is my acid. According to your reference table, we have these indicators. So if you happen to have any of these, methyl orange, that should look familiar to you, phenolphthalein, you could put that in your solutions. And if it stayed colorless, the pH would be less than 8. And if it turned pink, then the pH would be over 9. So it doesn't really give you a specific thing. It just tells you, it's either less than 8 or it's over 9, so you could tell strong bases. Something like litmus will work pretty well because it completely changes colors from red to blue. So if it's less than 4.5, it's red. If it's over 8.3, it's blue. It's difficult to tell in the middle range there what it's going to be, but if it's a strong acid or if it's a strong base, then you can use litmus to figure it out. But again, who has these in their kitchen so that you can tell which is an acid and which is a base? Well, another thing that you can use, if you happen to have red cabbage, which, I happen to get some, you take some red cabbage, you boil it up, and you make a solution out of it. You take the liquid that comes off of it, and you end up with this type of solution. And it looks like just red cabbage. But turns out, if you take that red cabbage and you put it in an acid, look what happens. This is the color it should be in my cheap glass. And it turns red in acids. But if you take that same container and you put it in a base, look at that. So we now know, if we know that cabbage turns red in acids and blue in bases, then you know which is which. And the thing with indicators is they really don't change your solution. So I could still use this as an acid. I could still use this as a base. Okay, so how you can do this at home. So you can investigate some different things around your house. Here I have 5 different containers of cabbage juice. I'm going to just take something that I think should be acidic. So based on the, sour taste of this and, common knowledge, I'm going to put some lemon juice into this first cabbage juice solution. And I don't know if you can see what's happening, but we have an obvious color change. It's much more noticeable in person. Oh, there we go. Stir it up a little bit. You can see there, cabbage juice works really well. It's going to turn red, and if you remember from before, red means it's acidic. So we have proof that lemons are actually acidic, and if we, we'll do it. It's very, very good. It's going to be acidic. So then, let's take something like some seltzer. Strawberry carbonated beverage. It's carbonation. Carbonic acid might be in there because it's got some fruit in it. What happens if you put soda? Oh, and notice it is changing color, but it isn't as drastic a change as the lemon is. right? But it is changing a little bit acidic. So then we have our soda, that won't fit in there. So we have our soda is a little bit acidic. So then we're going to keep this as our neutral color. So that's our purple is our general neutral color. Add some water to that just so you can see it a little bit better. That helped. Okay. So we have 2 more containers. What else can we test? I've heard that eggs might be a little bit acidic or basic. They have a tendency to do this. So I need to crack the egg. See my cooking skills here. Crack the egg with one hand. Get that in there. Is that going to change at all? Is that acidic or basic? Oh, look at that. There is a slight blue that's kind of blue-green that's kind of happening. So look at that. It turns out eggs are a little bit basic. They have a bitter taste associated with them. They are slimy, but they aren't melting your skin at all. But you can see there's definitely color change going on. Do we have anything else that would be basic in our house? As we talked about yesterday, a lot of cleaning solutions are. So you take your drain cleaner, you can always test to see if it's an acid or base. If you happen to have some kind of indicator around, this should be in liquid form, but it'll dissolve once we put it in there, I hope. Ooh, that's changing a lot. That is strong. Oh, that is absolutely... That actually looks a little bit acidic, doesn't it? I think I just put... It's getting warm. We have a chemical reaction going on there. It's cleaning the cabbage out of the drain. I'm going to put this over here just in case the glass breaks. Excellent. We definitely know that cabbage works as an indicator, and we've got some type of reaction going on there. So, what we have in your packets that you're going to be getting on Thursday, I didn't put cabbage leaves in there for you to experiment on your own. Instead, I gave you tea bags. I am told that tea works as an acid-base indicator. So I provided you with 2 or 3 bags. You can whip up some really strong, make it as strong as possible, tea, and then try some different things and see if it's an acid or a base, and report to me as to what your experiment holds. On Thursday at 3 o'clock, we're going to be talking about different indicators and doing some practice questions. And on Friday, we're going to be doing a bunch of experiments. So either one of those days, do your experiments and let me know what you come up with.